So we're going to have a quick look at what we mean by collision theory and how it relates to the rate of a chemical reaction. So if we think about a really straightforward reaction, so the reaction, for example, between hydrogen and chlorine, so a hydrogen molecule there and a chlorine, remember that we would call these the reactants, that they would react together and to produce two molecules of HCl or hydrogen chloride. And we would call these the products. So this shows just one collision or the overall process that's happening. But actually, if we were to look at any container with hydrogen and chlorine in it, we would have hundreds, if hundreds of millions of molecules. And these molecules would all be moving randomly. And there is a chance occasionally that these molecules could hit each other. And we call that process a collision. So if we look at one particular collision, then this would be a hydrogen molecule, and this would be a chlorine molecule, and they could hit each other, and most of the time, nothing happens. And that's because these collisions don't have enough energy. Sometimes the collisions do have enough energy, or sometimes we can increase the amount of energy they have, or the chance of them having a larger amount of energy. And in that case, we call that a successful collision. And in this case, a reaction would take place. And we determine a successful collision as one where the reactant particles have energy greater than or equal to the activation energy. And this is a really important term here, activation energy. And activation energy is the minimum energy needed for a reaction to take place.